Okay. Welcome. We will be looking at the rational root theorem. Rational root theorem. Rational root theorem. So, from the rational root theorem, we get subtypes or applications. We will get things like the factor theorem. That's actually the other name, or the remainder theorem. Okay. So rational root theorem is synonymous with the factor theorem and the remainder theorem. It's basically the same. It's just the applications that differ slightly. Okay. So now, what's the use of this? This is a way of factorizing big expressions. So in mathematics, big expressions generally will be called polynomials. So this is a way of factorizing big expressions, or generally polynomials. It can also be used to find the remainder more directly than using long or synthetic division. Okay. So, what are the other names for the rational root theorem? Just help me by typing this and that up. What are the other names for the rational root theorem? What are the other names for the rational root theorem? Quickly. What are the other names for the rational root theorem? Quickly. I need to know that we are moving as one. What are the other names for the rational root theorem? So factor and the remainder theorem. Thank you, Ruben and Abraham. It would be difficult to say Abraham. Got you this one. Okay, good. So it is a way of factorizing big expressions. So big expressions are called polynomials. Okay. So if you have x to the power 2, it is called a quadratic. If you have x to the power 3, it is called a cubic function. But if you reach x to the power n, where n obviously is greater than 3, generally it will be called a polynomial. Okay, but sometimes even x to the power 3 is considered to be a polynomial, even though it has its own name. So a polynomial is basically an expression with a very big power. So let me run you through the steps of using the rational root theorem. Okay. So steps. Only focus on the first and last numbers. For instance, we've been given ax to the power maybe 5 dot maybe plus bx to the power 4 plus cx to the power 3 plus dx to the power 2 plus ex plus f. Your interest would just be the first number, the coefficient of the first number, and the last number, which is the constant. These in the middle, you ignore. So ignore the middle. Just type up ignore the middle. If you learn that you have to ignore the middle, automatically your focus shifts to the first and to the last. So only focus on the first and last numbers. Okay, you ignore the middle. So type this up. Ignore the middle. Okay. Ignore the middle part. Just focus on the extremes. Good. Next, write down all the factors in brackets, positive and negative. Positives and negatives of A and F. Okay. Write down all the factors, positives of A and F. Next, start substituting the factors, and you know you've hit the jackpot if a substitution gives you 0. So when you substitute and you get 0, then that is definitely a number that you are looking for. So I know as words this can be a bit confusing unless I give you an example. Okay. Yeah, so let me give you the first example. Factorize. This is how they come. Factorize. X to the power 4 minus x to the power 3 minus 7x squared plus x plus 6. So our interest will just be the first number, this one, and the last number, that one. So these in the middle, we said we ignore. It doesn't matter how many they are. Ignore. Okay. So just focus on the first number and the last number. So we'll write the first number, that will be 1, and write the last number, that will be 6. Then we ask ourselves, what are the numbers that can go into 1 and which numbers can go into 6? Both positives and negatives. So in 1, positive 1 can go in. Okay, good. Again, inside 1, negative 1 can also go in. So the simple way is, anytime you think of a factor, write both its positive and its negative forms. That makes it easy. Rose Peary, how are you? Rose Peary was among the Jobbies last year. She's going to pass. She's serious. She was serious with school. We don't know about second year. Then 6. Can you guys help me with the factors of 6? List down all the numbers that can go into 6. Quickly, I'll give you a minute. What are the factors of 6? Quickly. You people got my 6 points. This can be giving you a headache. Okay, 2, 3, and 6. All right. So 1 should actually also be there. So positive 1, negative 1. Positive 2, negative 2. Positive 3, negative 3. And 6 itself, positive 6, negative 6. So these are what we call possible zeros. So possible zeros. I'll explain shortly why we call them zeros. So we now just list all of them in one line. Now, if there are numbers that are appearing twice, just write them once. So possible zeros will be plus 1, minus 1. Positive 2, minus 2. Positive 3, minus 3. Positive 6, minus 6. They are called zeros. So let's write. They are called zeros if, okay, they give you a 0 after substituting. Remember we said you are only interested in numbers that will give you a 0 once you substitute. They should give you a 0 once you substitute. So any number that gives you a 0 when you substitute it is basically just called a 0. So let's try substituting. So we'll call this function f of x. So f of x is going to be x to the power 4 minus x cubed minus 7x squared plus x plus 6. So we start substituting these. So let's try f of 1. When you try f of 1, what does it give you? Wherever there's an x, you put 1. What does it give you? Try and do it, and then I'll do it with you. When you try f of 1, what does it give you? What does the f of 1 give you? F of 1. Wherever there's x, put 1 and solve. What does that give you? Gives you 0. Okay. So let's try that. This is going to be 1 to the power 4 minus 1 to the power 3 minus 7 times 1 to the power 2 plus 1 plus 6. This will just give us 1 minus 1. This will just give us minus 7 plus 1. Then that will give us plus 6. So this 1 and the negative 1 cancel out. The 1 adds up with the 6 to give us 7. We get negative 7 plus 1 plus 6 will give us positive 7. Negative 7 plus 7 will give us 0. So we've plugged in x as 1, and that has given us 0. That means x is equal to 1 is a factor. The other name for a factor is a 0. So any number such that when you substitute it, it gives you 0 will be called a factor or a 0 or a solution. You'll be given the other names as we go along. Any number that when substituted gives you 0 will be called a 0, a factor, or a solution. Is it making sense? Yes or no? Is it making sense? I like to take my time when we're doing the introductory lessons so that later on when we need these cues, I will be sure you know them inside out. So are things making sense? Okay, good. So now, because the power was 4, we need to find 4 answers, and this was just our first one. Okay, that was just our first one. So there are several ways to go about this. Any anytime you find a possible 0, you have to divide using either synthetic or long division. Okay. Or the original one, you can just try plugging in other numbers and see which ones will give you 0. So this one has worked. Let's try plugging in -1. When -1 flops, we plug in 2. When 2 flops, we'll keep plugging in. We see which ones will give us zeros. So our expression is x to the power 4 minus x cubed minus 7x plus x plus 6. Let's now try f of -1. I'll be a bit fast now. -1 to the power 4 will give us 1. -1 to the power 3 will give us -1. So 7 times -1. Oh, sorry, this is supposed to be squared. So -1 squared will give us +1. Then plus -1. Then plus 6. We simplify. 1 plus 1 will give us 2. 2 minus 7. And then -1 and 6 will give us will give us +5. +5. Yeah. 2 and 5 will give us 7. So that gives us 7 minus 7. That gives us 0. Meaning x is equal to -1 is a factor. I told you in total we will need 4 factors. So far we've been able to find 2. Good. Let's go. We try plugging in another one. F of 2. So f of 2 being plugged in will give us 2 to the power 4 minus 2 cubed minus 7 times 2 squared plus 2 plus 6. 2 to the power 4, that is 16. Okay. 2 to the power 3, 8. Then that's 4. 4 times 7 will give us -28. And then 2 plus 6 will give us 8. Okay. So this 8 and that 8 cancel out. But the 16 and the 26 can give us 0. So this is not a factor. So since 2 has flopped, what's the next number that we'll move to? Since +2 has flopped, what's the next number that we should try? Since +2 has flopped, what is the next number that we should try? So you have to be very fast because you're doing all this in an exam and you're expected to answer other questions in addition to the one you attempted. So what other number should we try? Okay. Thank you, Mike. So we try -2. So f of -2. So that's going to be -2 to the power 4 minus -2 cubed minus 7 times -2 squared plus -2 plus 6. Okay. So -2 to the power 4. That is going to give us 16 still. Because the negative raised to an even power will give us a positive. Okay. -2 cubed will give us -8. So it will be minus -8. -2 to the power 2 will give us +4. So -7 times 4. -2 and 6 will give us +4. We simplify further. 16 plus 8. 16 plus 8, that will be 24. Okay. 24, -7 times 4, that will give us -28 plus 4. So -28 plus 4 will give us -24. That will be 24 minus 24. 24 minus 24 is going to give us 0. So what does that mean? Negative. So x is equal to -2 is a factor. So the highest power of this expression was 4. So far we've been able to find 3 factors. So we just need to find the third one. Okay. And we've been moving in order. We've tried this, we've tried that, we've tried this, we've tried that. The next number we should try is 3. Are things making sense, you people? Is everything making sense? Is everything making sense? Is everything making sense? Let me see if I can find you guys a question that actually comes in an exam paper so that you see how this whole thing is phrased sometimes. Okay, I can't seem to find the question now. Maybe I'll try and search for it later. Okay, good. Let's plug in positive 3. Remember, our original expression is x to the power 4 minus x cubed minus 7x squared plus x plus 6. We now try f of x, f of 3. So f of 3, that's going to be 3 to the power 4 minus 3 cubed minus 7 times 3 squared plus 3 plus 6. So 3 to the power 4, that's 3 times 3 times 3 times 3. 3 times 3 will give us 9. 3 times 3 will give us 9. 9 times 9 is 81. Minus 3 cubed. That's going to be 9 times 3, which is 27. So minus 27. 3 squared will be 9. That will give us minus 7 times 9. Plus 9. So 7 times 9. 7 times 9 will give us... 7 times 10 would have been 60, or rather 70. Then 70 minus 7, 63. So 81 minus 27 minus 63 plus 9. Okay. 81 plus 9 will give us 90. 27 and 63. 7 and 3 will give us 0, remainder 1. 6 plus 2 will give us 8, plus 1, 9. So 90 minus 90, what does 90 minus 90 give us? I failed to calculate this one, so I need your help. What is 90 minus 90? What is 90 minus 90? Let's see, I'm a genius. Okay, so Prosper, lithium ion, 0. Excellent, so 0. So that means x is equal to 3 is a factor. So now, let's list all the factors that we found. So our first factor was, where are the papers? Okay, so our first factor was x is equal to 1. Our second factor was x is equal to negative 1. Our third factor, x is equal to negative 2. And our fourth factor, x is equal to 3. So we've listed down the factors. Now, they didn't ask you to solve this question. They asked you to factorize it. So factorizing meaning your final answer should have brackets. So now what you do is each of these numbers should cross the equal sign if you are to put them in brackets. So just type up cross the equal sign. I need to make sure you people understand this. We need A pluses. So each number will cross the equal sign. So just type up cross the equal sign. You people type and you have autocorrect. Some of you even have fancy phones. You just have to say and it types for you. So cross the equal sign. Good. So in these crosses, we get x minus 1. That will be our first factor. The next factor will be the negative 1 crossing. It becomes plus 1. So that will be x plus 1. The next one will be x plus 2. The next one will be x minus 3. You are done factorizing this completely. Okay, so that is about the rational root theorem. I hope that has made sense. Are we cool? Are we cool? Okay, good. So tonight, maybe around 21, we will have another lesson, and then you people can have the quiz tomorrow. Yeah. Okay. Enjoy your morning. We will chat this evening. There are certain things I need to make sure you understand, so that when I give you a quiz, you people should sweat. All right. Bye-bye.